Welcome to our next week of virtual learning. You will notice we switched the order around of a couple of different lessons, so this should be week 3. Your next week's lesson, I believe the video says week 3 as well, though it will be the correct video for week 4. But this lesson for this week is on probability of compound events, introducing what you're going to see in week 4. And it is going to involve creating tree diagrams and finding probabilities from those tree diagrams. So we'll show you a few examples here. You're going to have 2 assignments this week. One will be a sheet with 1 question on it that has multiple parts. And then the second thing will also be a worksheet, which will just be a review of some probabilities. Even though it is 2 worksheets, I feel like they're both relatively short. They shouldn't take you too long to complete. But again, I would probably jot down these tree diagrams in your notes, either printed or if you want to write it down on a piece of paper, that works as well. So we'll start off with some key vocabulary. The first word is the sample space. We also sometimes call this the outcomes. It's the set of all of the possible outcomes in a probability experiment. We can go really simple with if we roll a die and our possible outcomes or sample space are 1, 2, 3, 4, 5, 6. Or we could get more complicated like in the situation today where we have multiple events occurring. So maybe you're going to create a sandwich and you're going to choose bread, meat, and cheese. Maybe you're going to an ice cream shop and you're choosing your type of ice cream and then all of your different toppings. So that would create our sample space, the outcomes that we could possibly get. We can go from a small number to a really large number, which we sometimes see when you go to a sandwich shop or you go to an ice cream shop. They talk about all the different combinations of sundaes and so forth, or sandwiches that you can make. A tree diagram is just one way that can be used to visually represent the sample space. If your sample space is 20, 30, 40, 50, or even higher, a tree diagram probably isn't your best way to represent this. You probably wouldn't even list all of the outcomes in that case, just because it could get really complicated. But a compound event is going to consist of 2 or more simple events. So that example I gave you where maybe you're going to build a sandwich and you're going to choose the bread, which is one event, and then you're going to choose the meat, which is the second event, and then you're going to choose the cheese, which is the third event. That would be a set of compound events that we'll be working with in this lesson, which is a pretty short lesson, and then next week's lesson, which is a little bit more in depth. So let's go into our first example. So there is an example typed up for you here, and it says a diner offers coffee, tea, and juice to its customers. They also offer bagels, muffins, and danishes. How many different combinations can be made if the customers must select one beverage and one bread option, and then list the sample space? So the first thing I always do is I list the events across the top, and these are the things that we're choosing from, the things that we have a choice for. There are labels. So we want to be really careful there. Sometimes students have trouble listing or naming the different events. So in this case, we have to choose from the beverage and the bread. I just call it the bread just to give us a general name there. So it doesn't matter which order you list these in. So you could do bread and then beverage, but I just chose beverage first since that was listed first, and then bread. Underneath your event, you're going to list the outcomes for that event. So for the beverage, we have 3 different outcomes: coffee, tea, and juice. So notice how I list those going down. I do spread them out a bit because I'm going to have some branches, just like a tree, coming off of each of those different outcomes. Now, for the bread, let's say I choose coffee, then I can choose either a bagel, muffin, or Danish. So notice I have 3 branches coming off of coffee. I'm also going to have those same 3 branches coming off of tea and the same 3 branches coming off of juice, because if I choose any of these beverages, I can still choose any of these 3 possible bread options. Now, when we go to list the sample space, we're basically going to follow these arrows. So I'll go through a couple of them. So let's say, for example, let me go ahead and highlight this. Let's say I'm going to list my first item in the sample space, coffee, bagel. So I would start off with coffee, and then I would follow this branch here, and then bagel. So my next one I'll highlight in green. I start off with coffee, And then I'm going to go over to muffin. So it'd be coffee and muffin. My next one would be coffee and then Danish. Okay, so just following those through and then naming them. So again, coffee, bagel, coffee, muffin, and then coffee, Danish. So then we go to our next outcome that we have for beverage. So we have tea, bagel, tea, muffin, and tea, Danish. So we have those three listed. And then finally, if we choose juice, we have juice, bagel, juice, muffin, and juice, Danish. We have a total of 9 possible outcomes. And the way we figure that out is we basically count these up. So we have 3 up here, 3 here, and another 3 down here, and that is going to give us a total of 9 possible outcomes. Yes, Oliver. So we have 9 possible outcomes here. Okay. One other way you could figure out if, let's say, you didn't need to list the sample space or all of the possible outcomes, you could figure out how many elements are in the sample space by looking at each of your events. We had the beverage and we had the bread. And for the beverage, we had 3 possible outcomes. Go ahead and type that in. So for beverage, we had 3 outcomes. For our bread, we had 3 possible outcomes. And if you take 3 times 3, that gets you 9. So if you actually multiply the number of outcomes for each event, it will tell you how many total outcomes you have. Tree diagrams themselves aren't complicated, but again, you have to start by making sure you list the events correctly. And then again, off of each of these, yeah, you're going to list whatever your second event is, you're going to list those elements more than once, depending on how many outcomes you had for your first event. So let's try a few of these. And I only have one of these for your practice sheet. I would suggest using abbreviations. Like, you don't have to necessarily write out the entire word. Like, you could use C to represent coffee. It's easy for me because I'm just typing these in, but usually in my notes, I just use abbreviations for each of those elements. So taking a look at our first example here, in number 1, it says a deli offers white or rye bread, ham or turkey, and Swiss cheddar or provolone cheese. Draw a tree diagram to find the sample space for a sandwich consisting of 1 type of bread, 1 type of meat, and 1 type of cheese. And again, I did say there that you can use abbreviations instead of having to type or write them all out. So the first thing I'm going to do is I'm going to list all of my events across the top. I can choose from the bread, the meat, and the cheese. And again, that even says it right here in the description. We've got 1 type of bread, 1 type of meat, and 1 type of cheese. And then I'll list my sample space at the end. So let's go ahead and create our tree diagram. I'll show this all at once. But for the bread, I have 2 choices. In a normal circumstance, you would probably have more choices, but I've got white or rye, and again, I spread them out to make sure that I have enough space for the rest of my tree diagram. This does take some practice. For the meat, I have ham and turkey. So off of white, I've got ham and turkey, and off of rye, I've got ham and turkey. Now, off of each of my meats, I have 3 different choices for the cheese. I've got Swiss cheddar and provolone. So notice I have 3 branches coming off of each of the meats. 3 off of this ham, 3 off this ham, 3 off this turkey, 3 off of this turkey. If I want to figure out my sample space, again, I'm just going to follow those branches. So notice how I did use abbreviations here. So I've got WHS, excuse me. That's white, ham, and Swiss. And then I go white, ham, cheddar, white, ham, provolone. Now I go down to turkey, white, turkey, Swiss, white, turkey, cheddar, and white, turkey, provolone. Then I go to the rye bread. I've got rye, ham, Swiss, rye, ham, cheddar, rye, ham, provolone, rye, turkey, Swiss, rye, turkey, cheddar, and rye, turkey, provolone. Again, you can feel free to use abbreviations there. You don't really need the little commas between there either. If you just want to put like RTP, that's okay too. Now the question is, how many total outcomes are there? Well, I add up how many I have in this final set of branches here, and I should have 12 total outcomes. I can also figure that out by saying, okay, for the bread, we had 2 possible choices. For the meat, we had 2 possible choices. And then for the cheese, we had 3 possible choices. 2 times 2 times 3 is going to get us 12 possible outcomes. Now we do have some probability questions related to this, which I think are also pretty good to look at. It says, what is the probability of a customer choosing white bread and ham? So basically I want to go up here and figure out which choices involve white bread and ham. So that is going to have a W and an H involved. So I'll highlight this in green. That's going to be this outcome, and this outcome, white bread and ham. The rest are going to either involve rye bread or white bread and turkey. So it's 3 of my 12 outcomes. So the probability is 3/12, which reduces to 1/4 or 25%. The last question with this problem, what is the probability of a customer choosing turkey and provolone cheese? So I need a T and a P involved here. And I'm going to highlight this in green. So I've got this outcome right here for turkey and provolone, and then this outcome down here, which includes turkey and provolone. And that happens to be 2 of our 12 outcomes. And 2/12 is going to reduce to 1/6. That is 16.6 repeating percent. If you put about 17% or 16.7%, that's okay too. But we go a little bit further here. What I like about listing all the outcomes is it makes it easier for us to find some probabilities from that. All right, let's do another example. Now, 2 and 3 you're going to notice are very, very similar because they are essentially the same situation, except for one involves coins, and then the other one is going to involve the gender of babies that are being born. So number 2, it says a coin is tossed 3 times. Draw a tree diagram to show the sample space. So a lot of times when I have students who list the events, they list the events as like heads or tails, but those are not the events. Those are the outcomes of the events. Our events in this case are the 3 tosses of the coin. So when we go to list our events across the top, the way I listed this was toss 1, toss 2, toss 3. If this were tossed just, let's say, 2 times, then we would have toss 1 and toss 2. If we had it 4 times, it would be toss 1, toss 2, toss 3, toss 4. So now our outcomes for each of those events, that's the heads or tails. So for toss 1, it can be heads or tails. For toss 2, it can also be heads or tails. So if you get heads on toss 1, then you could get heads or tails on toss 2. If you get tails on toss 1, you could get heads or tails on toss 2. Then for toss 3, we have the same outcome. So off of each of these guys, we've got to have 2 branches coming off of those. So when we go to list our sample space, we've got heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. And that is, by the way, a total of 8 outcomes, which kind of makes sense because for each of our 3 tosses, we have 2 possible outcomes, heads or tails. 2 times 2 times 2 would get us 8 possible outcomes. The next question says, what is the probability of all coins landing on heads? This should be a fairly easy question. There's only one outcome where all 3 coins, where all 3 coins land on heads, and that's this one. So 1 out of the 8 possible outcomes, which is a probability of 1/8, that is 12.5%. I still have people asking, how do I determine what the percentage is? Take your top number divided by your bottom number. So 1 divided by 8 gets you 0.125, which is 12.5%. So our last example is going to actually be very, very similar. We do have 2 probability questions related to it, except it involves gender. So Mr. and Mrs. Rodriguez are expecting triplets. The chance of each child being a boy is 50%, and the chance of each child being a girl is 50%. Draw a tree diagram to show the sample space. So when you were in science class, you probably actually saw some questions with this. You guys did a genetics unit and you did Punnett squares and things like that. So you probably also worked with some things similar to this in science class as well. There is a nice overlap there. So my 3 different events are the 3 triplets. So triplet 1, triplet 2, and triplet 3. So for triplet 1, it could be a boy or a girl. For triplet 2, same thing, and same for triplet 3. So we've got, off of if the first triplet is a boy, the second could be a boy or a girl. If the first is a boy, the second is a boy, the third could either be a boy or a girl. So notice how we have these branching out. And again, just be careful. Make sure you're copying this down correctly. Students do sometimes struggle with creating these tree diagrams. But off of each thing, if you have boy for the first one and you've got two outcomes for the second triplet, you've got to have two branches coming off of there. And then if you have two outcomes for the third triplet, you got to have two branches going off of there as well. So this really is the same tree diagram as the coins, except for, because it essentially is a coin toss, except we have B and G instead of H and T. So my sample space, my outcomes will be boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. Now keep in mind, two girls and one boy is essentially the same in the long run. This is specifically looking at the order in which they're born as well. We again have 8 total outcomes, which makes sense. 2 for the first triplet, 2 for the second, 2 for the third. Now, our probabilities. So what is the probability that all 3 children will be girls? Well, there is only one outcome there. That is this outcome right here. So it's 1 out of the 8 possible outcomes, which just like our last problem is going to be 12.5%. Now, the second question is a little bit more interesting. What is the probability of 2 boys and 1 girl? So for this, we've got few outcomes with 2 boys and 1 girl. Let me highlight this in green. So here we've got 2 boys and 1 girl. For this, make sure we've got this here. For this outcome, we have 2 boys and 1 girl. And for this outcome right here, we have 2 boys and 1 girl. So we're looking to see how many of those outcomes we've got 2 boys, 1 girl. Let's just double check and make sure we got them all. So that should be 3 out of the 8 possible outcomes, which is 37.5%. And again, 3 divided by 8 is 0.375, which is 37.5%. Those are kind of tough questions. I know in pre-algebra we typically do a question where it says, what's the probability of at least 2 boys, or at least 1 boy, or at least 2 girls? That can make things a little bit more challenging and a little bit more tricky. But it's good for us to take a look at problems like this. Now, in our next lesson, what we'll be looking at is, this will be next week, we'll be talking a little bit about probability of compound events and finding those without having to necessarily make a tree diagram every time. So we'll go through that with next week's lesson. For this week's lesson, though, once you've finished watching this video, which is about to end, you have 2 worksheets to complete. So make sure you get them both completed. One is a tree diagram, and then the other question will be just a review of probability. Thanks for listening, and Ali says bye-bye as well.